All right, day 2 of these transformations. Great job on reflections. Please make sure that you keep those or that little like cheat sheet on the reflections handy. You're going to need it today. I mean, I'll go over it again as well, but you will need to make sure that you have those, I guess, formulas, you could call them, available to you at all times, because you are going to start doing today these things called compositions. So today we're going to start out by talking about a translation. A translation is basically you taking a figure and you're sliding it left, right, up, down, diagonal. So a translation is a slide. And again, we would normally slide on a coordinate plane. We're going to talk about it on a coordinate plane, but we're not actually going to be graphing these. So there's 2 different ways that you're going to see translations, like their notation. The first way is with a capital T, and then there's going to be these vectors. It's called a vector. If you have ever watched Despicable Me, the vector is the, I think he is the bad guy in there. I think my kids have always watched that. But this is vector notation, and then there's always going to be a number here and a number here. So these numbers, though, tell you how the X or how the Y move. So this is called vector notation. The other way that you're going to see it is written as a rule. So they'll have in parentheses X, Y, and then what you do is they're going to say like X plus 1, Y minus 5. So that's another way that they're going to show you. So what this means is take your X value of your coordinate, add 1 to it, take your Y value of your coordinate, subtract 5 of it from it. In vector notation, that would look like this: +1, -5. So they mean the same exact thing. It's just 2 different ways to notate it. Me personally, I think vector notation is a little bit faster and easier, but sometimes we get so caught up with the coordinates that sometimes just knowing how to write it as a coordinate works as well. So I want to show you a couple of examples, or maybe just even 1 or 2 examples. I'm aware that this is not in your note packet. Many people did not get the note packets from me, so I didn't want to keep doing notes in the note packet to confuse people. But if you have the note packet, this is going to be example 1. So first example that we're going to walk through. In your note packet, it would have a graph. We're not graphing, but what I want you to do is I want you to translate with the vector 7, -4, triangle EFG. So they're going to put triangle EFG like that. So this means that I'm going to take every single X value, move it +7, every single Y value, move it -4. E has the coordinate -5, 4. F has the coordinate -1, 5. And G has the coordinate -2, -1. So these aren't numbers that I'm just like, these are numbers I'm kind of just coming up off the top of my head. If you had your notes, you would see this is the coordinates of the actual triangle. But these are just the coordinates, the originals. Just like with the reflections, now we're going to end up getting the primes. So I am going to take now to get E prime. This is my vector. My vector says 7, -4. So what that means is I am going to move every single point right 7, down 4. And if you think about this in terms of like just coordinates, I'm going to take every single X value, add 7, and I'm going to take every single Y value and subtract 4. And that's really all you're doing today, is you're either adding or subtracting to your coordinates. So if you get confused, grab a calculator, use your phone, use your Chromebook calculator, and do the operations there. So E prime, if I take -5 plus 7, I get 2, comma, 4 minus 4 is 0. So there's my new coordinate. F prime, so again, I'm doing the same thing. I started with F. Now I'm going to apply my translation here. -1 plus 7 is 6. 5 minus 4 is 1. And then G prime, -2 plus 7 is 5. -1 minus 4 is -5. So these are what my coordinates would end up being. That's all you're doing today. Well, part of it, half of it. So another example, just to make sure everyone knows what's going on, I'm going to write it in a different way, is I'm going to take this same exact triangle up here. So I'm going to take E at negative 5, 4. I'm going to take F at negative 1, 5. And I'm going to take G at negative 2, negative 1. And I'm going to apply a translation. I'm going to write it a little different. I'm going to write it as a rule. And I'm going to have X minus 6, comma, Y minus 7. So they would actually have the XY here, and this they would show that's how the rule is. So it's the same idea though as what we did up here. We're going to take every single X value, and we're going to subtract 6. And we're going to take every single Y value and subtract 7. So then that gives me my E prime, negative 5 minus 6 is negative 11. 4 minus 7 is negative 3. So there's that new coordinate. F prime, negative 1 minus 6 is negative 7. 5 minus 7 is negative 2. And then G prime, negative 2 minus 6 is negative 8. Negative 1 minus 7 is negative 8 again. And these would be my answers. Again, make sure when you're typing these in, there's no spaces or anything like that. But that is just simply doing translations. You're either adding or subtracting from your X and Y values. So the other thing that we're going to talk about today are these things called compositions. Compositions can get kind of tough if you don't fully understand it. And I know that this video is taking a little bit longer than normal. So just bear with me or pop into the Google Meet and I can probably explain this a little bit faster. So what a composition is, it's where you have two or more transformations occurring at the same time. So we've only learned 2 transformations so far. We've only learned reflections and translations. So those are the only ones that are going to be kind of fair game. So like for instance, if I had 2 translations, we'll say. So if I had a translation that went, let's see, 3, negative 2, and then they use this little symbol. This right here means composition. And then I had another translation that went 1, negative 1. They want to know then if I have this translation and I move a point this much, and then if I do another translation and I move a point this much, how much did I actually move? So if you think about it, if I took a point and I moved it 3, that means I went plus 3 on the x-axis. And then I took another point and I took that same point and I moved it now 1 more, so plus 1. How much did I total move? 4. And let's say I had, for my y value, minus 2 means, well, obviously I went down 2. And then this one goes down 1. So negative 2 and negative 1 give me negative 3. So when you have 2 translations, just add the coordinates. And that's really what we're doing here. 3 plus 1 is 4. Negative 2 plus negative 1 is negative 3. Gets a little hairy here with this next one. We're going to take a point, points, plural, and we're going to do a translation and a reflection. So let's take a look at this. So if we have, this will be like example 3 at this point. If we have a triangle that has a point A at 0, 0, a point B at 0, 3, and a point C at 3, 0, what we want to do is we want to take this, we want to do a translation of 3, negative 2, composed with, so and, we want to reflect over the y-axis. So when you have 2 different things going on here, this is where it's going to get weird, and I hope that I didn't lose anyone at 10 minutes into this. You actually work backwards. So whenever you have a composition, and those who are in Algebra 2, or when you get to Algebra 2, or maybe even when you take a trig pre-calc class, we do compositions of functions. This is kind of the same thing, and you work backwards. So we actually are going to take our points, and we're going to do the reflection first. So we do this first, and we do this second. So if you're going to mess up anywhere, that's where you're going to mess up. So if you go to type your answers into Go Formative and it tells you you're wrong, I bet that's the issue. So first thing we're going to do is the reflection. So we're going to take our points and we're going to reflect it over the y-axis, which if you remember from Monday or Tuesday, the last time that you had me, the reflection over the y-axis, all that changes is the x value. So we're going to take our points. A is at 0, 0. B is at 0, 3. And C is at 3, 0. And we're going to apply the reflection. So when I apply the reflection, that's when I get my A prime, B prime, and C prime. So when I reflect, the X value changes signs. Well, I have 0, so just leave it as 0. And the Y value stays the same. So A prime doesn't change because 0, you can't have a negative 0. For B prime, again, whatever the X value was, change the sign. Well, you can't have a negative 0, so just leave it 0. And the Y value stays the same, so it stays at 3. So far, it's the exact same thing. C prime, though, the X value changes signs, so it becomes negative 3. The Y value stays the same. So these are my points after the reflection. Now I need to apply the translation, which the translation says that you are moving 3, negative 2. So now I'm going to take every single one of these points and I'm going to apply the translation of 3, negative 2. And what that means is I'm going to take all of my x's and I'm going to add 3. And I'm going to take all of my y's and I'm going to subtract 2. And what it gives me, so these are my primes. So the more transformations you keep applying, you just keep slapping these primes on top here. So A double prime would be 0 plus 3 is 3. 0 minus 2 is negative 2. B double prime, 0 plus 3 is 3. 3 minus 2 is 1. And then C double prime, negative 3 plus 3 is 0. 0 minus 2 is negative 2. This would be your final answer. We're looking for your double primes. So you have to be careful because if you get these wrong, most likely, this is what I'm going to tell you how you can kind of figure out what you did. If you get these wrong, the first thing that you need to remember is that you do this first, then this. So do the reflection, then the translation. So a lot of times we are so used to going, we read, we do everything left to right, except for compositions. You work right to left. So be careful with that. If you show up to the Google Meet today, I will be going over additional examples. But if this was confusing, pause it, rewind it, go back and see if you have any questions and then reach out.